Hello students, today we are in lecture number 45. I am S Pandey. My dear students, hopefully it would be the last lecture of chapter number 3, that is the current electricity. Then we'll proceed for the chapter number 4 from next lecture. Okay, my dear students, that we are successfully just concluding today the chapter number 3 here. We are in lecture number 45 of chapter 3, current electricity. Okay, my dear student, we have studied all the topics, we have discussed, we have covered all the topics that are very important for your board examination, and that is mentioned in your NCERT. All right, so we have discussed the topics which are in our course. The one topic it is left, the electrical energy and electrical power, that we'll discuss today. That is very important, and we'll do some questions. Remember, this particular topic you have studied in your standard 10 also, and it was very interesting in standard 10. Try to recall that you used to calculate what will be the electricity bill at the rate of 4 rupees if your consumption of electricity of electrical power it is 10 unit or the 20 unit. I hope you are able to recall that such type of question we have done. Okay, my dear student. So today we will not do such type of question, but we'll do some question of our label. So first we are going to start with the electrical energy. All right, it is electrical energy. To understand this electrical energy, let me discuss with a very simple thing, my dear students. Okay, that I adopt this particular concept from a teacher. I'm telling you, and this was very fantastic. That's why I'm discussing over here. One resistance, it is connected with the source of EMF, that is the battery or the cell. The resistance is R. All right, here the plus and minus. My dear student, this battery used to work for the resistance, and to study the energy or the work, we know that we have studied in electrostatic chapter what is work done by this battery. Actually, this battery leaves the charge, and that charge do some work at some potential. Okay, if the potential of this battery is V, all right, then what will be the potential at this point? Of course, you will write 0, sir. Yes, exactly. And at this point, exactly, it will be the 0. But what will be the potential at this point? It is V, exactly. And at this point the potential is V. Where this potential has been gone while moving across this resistor? Yes, actually the potential drop across this resistor. That's why you are again having the potential 0 over here. As you are moving across the resistor, you can see the potential drop across the resistor. That's why you do have the value of V the same it was at this point, my dear student. Suppose a charge start moving from here. It is the charge Q. Okay, what is the energy of charge over here? It is the Q times V. We know that, but the potential is 0. It means the energy is 0. Here the energy is also 0. But as we move from this point to this point, this charge is full with the energy. And what is the amount of energy at this point? It is Q times V. You can write here the charge times potential. It is Q into V. Yes, and what will the energy over here? The same, because no equipment over here. That's why the energy remains same. It is the Q times V. All right. But as you go from this point to this point, what will be the energy? Actually, where this energy gone? This QV becomes 0. Actually, this energy is just withdrawn by this resistor, and that energy that withdraw by this resistor we have to study in this section. Okay, and that is the electrical energy. Actually, this energy lost on the resistor, remember, this energy lost on the resistor, and that energy we are going to study. This energy, the well discussed by the Joule, that has been mentioned in your course, like the Joule, as the Joule's law. Okay, we will discuss here. Before the Joule's law, let we find here the formula for the energy, that is this energy which is used by this resistor, often used as the heat energy. Okay, might be if this is the bulb or the mechanical energy. All right, so I'm writing, we are writing the Joule's law. This is the resistance, battery, resistance R, the current live by this battery or voltage V. All right, now suppose as this switch is on, the very small amount of charge dq start flowing through the circuit. Remember, without flowing the charge, or without study of the conventional flow of charge, we cannot study the current. That's why I have mentioned over here the charge. All right, and we know that work done, it is, what is work done? Actually, it is charge times potential. Suppose a very small amount of charge, and such type of small amount of charge continuously sent by the battery over the resistor. Actually, this charge become current, and this resistor used as the current. All right. Now, this dW is dQ times V. Using Ohm's law, we know that V is equals to IR, so we can write here that dQ is equals to I times R. Could we write here the I times R? Yes, very simple. And we know this dW, we know very well this I is nothing but the dQ by dt. We know, na? So dQ can be written the I dt. All right, write down here dW is equals to dQ, it is I dt times IR. It is I square R dt. Now integrate to get for a particular time. You started this cell, switch on this cell at 0 second. After t second, you want to find out the energy that is stored by, or the energy used by this resistor, my dear students. Then you will get, integrating this dW, I is constant. Remember, here the constant current is maintained. I square, R is constant. So the dt at 0 second, the energy was 0. At t seconds, suppose the energy, if it is bulb, then it is used in form of heat. So we can write this one as W dW, it is H and I square R times T. So this is the heat energy. I hope you got. This is I square R T. Now what was the Joule's law actually? The Joule's law was very simple. It was, according to Joule, what Joule experimentally found that if you will switch on a battery, the heat radiated by this resistor, remember this heat radiated by this resistor depends on three things. This heat depends on this current. As the current will up, here the heat will up. As the resistance will up, this heat will again up, and this time will up, thus current heat will again up. But there is a certain relation that heat depends upon the current as the square, all right, and linearly on the resistance and time. This was the Joule's law. According to Joule, the amount of heat radiated by any resistor directly proportional to the square of current resistor and the time for which the current is being flown through the circuit. This is the Joule's law. That is not very difficult. All right, my dear student. Now, you will use this particular formula to solve such a few questions, but before that we shall discuss about the power, electrical power. My dear student, remember this amount of heat which is radiated by the electrical bulb. Actually, whenever you will ask to find the energy of any bulb, or if you have been asked the question which bulb will glow more, it means you have to indirectly ask to find the heat radiated. Remember? All right. Yes. Now, electrical power. And what will be the SI unit of this heat? Of course, joule, because this is energy. Now, electrical power. We know that mechanical power also, but we are talking about here the electrical power. Okay, my dear students. And electrical power, we have discussed that work or the energy the energy we have also discussed. It is the Q times V. All right, we have discussed now. If you have maintained a resistor at some potential, what will be constant? Charge will start flowing from here, but V remain constant. All right, differentiating this W dW by dt and dQV over dt, this is the rate change of work. What is the rate change of work? So the rate of work is called power. So this is nothing but the power, and this is Q dV by V, the constant na, V dQ by dt. What is dQ by dt? Yes, it is current. So the power will be V times I. Very simple one. Alright. Now you can just convert this one in the different form also. Power. Its SI unit, try to remember, it is watt. The James Watt, the scientist, for the respect of his name, we use this watt as the SI unit of electrical power. Now you can convert this power in three ways. Using Ohm's law, that is the V equals to IR. Can you replace this I? Yes, we can replace by V by R. So the power will be V times V by R. It is V square by R. So you are having a formula for power. It is the V square by R. This is very important. Okay, and this is very important, and you must remember this formula. The one formula you got here, the V times I. The second one you got V square by R. Now the third one, could you replace this V? Yes, you can replace this V by IR. So this will be P equals to IR times I. So this power will be I square R. Okay, so we are having a formula P is equals to I square R. The another one. This is all are the very simple, my dear students. I hope that you are getting everything. Now, let me do some other very simple question. Okay, but before doing that question, one topic it is left. Let me finish the chapter first, and then after we'll start the practicing over the questions. I think it is the last class, because I am not getting any more questions to solve that you feel difficulty. Okay. So the next topic is efficiency of a cell, that is the source of potential. Okay. Efficiency of a cell. What is the efficiency of cell? Actually, what the cell do for us? Actually, cell deliver the power. It gives the output as power. So whenever you will talk about the efficiency, you have to correlate the powers. What the battery has given the power, and what the instrument got the power actually. It means using that power, what that instrument did as output. So efficiency, we know that efficiency is nothing but the output by input. Output by input. What we have input and what we got as output. This is the efficiency. The percentage, if you want to find, then you will multiply by the 100%. It becomes the percentage efficiency. All right. Here, now it is very important to discuss, if you are talking about the cell, the efficiency of cell, you have to draw a cell. This is a cell. Suppose the internal resistance of cell is R, the EMF of the cell or the voltage is V. We should write the EMF. Yes. Now this is the cell. All right. Connect this cell with a load resistance like bulb, fan, anything. This is the R, load resistance. What current sensed by the circuit, that is the cell, it will be I. Okay. What we have to find? Actually, we have to find the output power by input power. Now, the input and output. What is input and what is output? Output will be obtained across these 2 points. Let me write, this is A and B. So efficiency, we can write here the energy. All right. The or you can write the I think yes, you can write the energy, that is the E, or the power across AB divided by power of cell. This is the power, I think. All right. Now try to look at here, the power across the terminal AB, it will be the power minus power lost, that is the energy lost at this point. And we can write N as, here it will be the EI, the current is I, minus current is I square R, okay, divided by power of cell. Power of cell, it was E times I. Now you can find the formula, the simple formula. Could you find the I? Here I is nothing but the E by R plus R, I think. So the efficiency will be 1 minus this one divided minus I square R by EI. I will be cancelled out and it can be written the 1 minus I R by E. R by, yes, R by E. Now you can put the value of I from here. Okay. So it will be E by R plus R times R by E. E will be cancelled out and then this is 1 minus R by R plus R, and finally R plus R minus R will be cancelled out and you will have the answer. This is R by R plus R. So if you are having the resistance of the circuit and if you are having the internal resistance, then you can write the efficiency of a cell in this way. So this is the efficiency of a cell, my dear students. Okay. Now let me do some very easy question. Kindly note down. I'm giving you a circuit, all right, and you have to find the energy. This is example. The very simple question I'm giving you. I used to give very simple questions so that all students can solve. Let me connect a battery. All right, and this battery is for 12 volt. Okay, resistance 3 ohm, 6 ohm, and this is 4 ohm. That's it. If this battery is switched on for 2 minutes, how much time? For 2 minutes. then you have to find the heat radiated by all these three resistors in that 2 minutes. You have to find the heat by this all resistor in 2 minutes. This is your question, my dear students. Okay, try to solve. If you can solve, pause the video and solve this question. This is 12 volt. Remember, it might be the signing due to the flash of my phone, the camera. That's why I'm telling you it is a 12 volt. Now let me solve this question. First, try to find out the current. What will be the current? So here the current will be total voltage by total resistance. Now, what is the resistance? 6 and 3. These two are connected in parallel. So 6, 3 will be 2. 6, 3 is 18 divided by 6 plus 3, 9. So 18 by 9, it will be the 2. And then this 4 will be connected in series. So 2 plus 4, it is 6. So the current is 2 ampere. Now 2 ampere current is moving. Alright. At this point, how much current will reach? 2 ampere. So how much voltage will drop across here? 2 4s are 8 volt. 8 volt. Now how much potential left over here? The answer is 4 volt. 4 volt. I hope you understand. Now you have to find the energy. Suppose we are writing this is as H1, this is as H2, and this is H3. Alright, so the H1, alright, so H1 will be what is the formula? It is I square R. If you have the current across here, it is 2 ampere. How much current was here? 2 ampere. And the current over here, the voltage by resistance 4 by 6, and here the current is 4 by 3. Very simple, huh? Now current H1 I square, that is 2 by 3, it is I square. R how much? It is 6. T how much? 2 into 60 in second joule. Answer. The very simple, na? H2, the current here 4 by 3, that is the 4 by 3 I square. R is 3 and T is again 2 times 60 joule, and S3 it is I how much? 2 I square. R how much? 4 into T 2 times 60 joule. I hope no students left with any doubt over here. Now the next question for our practice. May I rub this? Okay. So my dear students, the next question. You are having 3 bulbs connected in first series and then in parallel. 3 bulbs, suppose first connected in series. We are discussing here the question for series with a source. Okay, with any source. Here this bulb and this bulb, B1, B2 and B3. Rating of these bulbs are given. The bulbs have been given the rating. What is the rating? Rating, it is 100 watt at 200 volt. This bulb was made for B1, B2, 200 watt. What is, let me do 40, 50 watt at 200 volt, and the B3, it is made up with 60 watt and 200 volt. You have to apply at 200 volt. This is the source. Now the question, which bulb will glow more? If these 3 bulbs are connected in series, the question is which bulb will glow more? And the same question I will change, if these three bulbs will be connected in parallel, then which bulb will glow more? Okay, the one question I will solve, and then after you have to solve this question by yourself of parallel. Now look at here, the current here, it will start moving and current remain same. I'm solving by taking general values. All right, here the current is I. Now which quantity remain constant, my dear student? Could you tell me? Yes, it is current, because voltage will drop at each bulb and it may be the different, because all the bulb are having of the different power. But it is very important to find the resistance of the bulbs. We know that P equals to V square by R. All right. So you can see all the bulb are made up with the same potential. Otherwise you can find out, you can calculate the resistance also, but you can see here for the same voltage P inversely proportional to R. Okay, so higher the power, the smaller will be the resistance. It means it is quite clear from this relation what R1 of bulb 1, because power is lowest, so the resistance will be highest, and then R2 and then R3. Alright, now which bulb will glow more? What does it mean? It means which bulb going to radiate more heat. This is the question actually. Okay, and we know that the formula for heat, because all the bulb will get current or voltage for same time, so the T remains same. Time is going not to be changed, so the T remains same. So the H is equals to, we know that I square RT. Now students will argue that, sir, V square by RT, we are having this formula also for H. Yes, my dear students, of course, but you can see here the voltage get by all the bulb will different. Remember, this is not the voltage 200, actually this was the rating of bulb. In company, the bulb was made up at 200 volt to maintain the power as 40 watt. Remember, dear student. Okay, so now look at here, the potential are the different. That's why we are using the current, because we are having the current same in all three bulbs, so we will use this formula. All right, using this formula, my dear students, you can see this H is directly proportional to R. Why? Because I and T are constant. H directly proportional to R. Higher the resistance, higher will be the heat. Okay, it means H1 will be greater than H2 will be greater than H3. So thus first bulb will glow more. Okay, and then this second one and third one will glow less. Okay, so this is the answer. Now you can solve this question by applying that if these three bulbs are in parallel, then what will be the glow of this three bulbs, which will glow more in parallel. Now write down here a homework, my dear student. I'm getting frightened. Sorry. Yes. I have to switch off my fan while making this video, my dear students, so that you will not get any noise. 1, 2, 3 and 4. These are the 4 bulbs. All right, and it is connected with a source. It is connected with a source of V. All the bulbs are identical. Listen carefully the question. All the bulbs are identical. You have to arrange this bulb according to brightness more. Which will glow more first, then after that, and then after that, and then least one. You have to arrange all the bulbs according to their maximum brightness. Okay, now one more question. All the bulbs are identical, remember. Identical, it means it is made up with potential, suppose 100 and power is 40, then 140, 140, 140. All right, this is. Now the third one. Okay, next. Yes, third question, because one it was, if three bulb will connect in parallel, which will glow more, and the second. And now the third question. Okay, you are having two rated bulb. One, it is 100 watt, 110 volt, and the second it is 50 watt, 110 volt. All right, if you connected this two bulb in series, okay, in series, listen carefully the question, in series with the source of just take 220 volt, okay, source of 220 volt, you find one bulb burst. Now the question, which bulb will burst and why? Okay, if you are connecting in series. Now the same question, if you connect in parallel, okay, with the same source 220 volt, you find one bulb get burst. Now again you have to tell me which bulb and why that will burst. Okay, so my dear student, today we are concluding this chapter number 3 of current electricity, my dear students. This is all about today lecture. Thank you, my students.